A car travels 30 miles in the same time that a motorcycle travels 25 miles on the Wangan in Greater Tokyo. If the car's speed is 15 miles per hour more than the motorcycle's, find the speed of the car and the speed of the motorcycle. So that's what they're asking us to find. The speed of the car and the speed of the motorcycle. So we know that those are two things that we don't know. We have to find out. But it talks about speed, which is rate, and it talks about time, and it talks about distance. So rate times time equals distance is an important formula that you might have seen before. So that's how we're going to relate knowns and unknowns with that formula. Rate times time equals distance. So rate times time equals distance here. That's how the table is going to work. So let's start filling in things here that we know. The car travels 30 miles. So that's the distance that the car is traveling at, or to. And the motorcycle travels 25 miles. If the car's speed is 15 miles per hour more than the motorcycle's. So we don't know the speed of either one of them, but the car is 15 more than the motorcycle. So since the car talks about the motorcycle will be our variable, because the car is 15 more than that. And so in this case, we're not finding the distance. We already have the distance. We're actually trying to find the time. So in this equation or formula, rate times time equals distance, if I wanted to solve for time, then I have to undo this multiplication of rate. So time is distance divided by rate. So in this case, the car, distance 30 divided by rate, x plus 15. And motorcycle, distance 25 divided by rate, x. And what do we know about the time then? It says in the same time, so that means I'm setting time equal to each other. So time of the car equals time of the motorcycle. And that relates those knowns to those unknowns there. Now we just need to solve this, and this equation is in two ratios in proportion. So I could just use cross products here. If I multiply 30 times x, that equals x plus 15 times 25. The order of the products doesn't matter. Multiplication is commutative, so I want to go ahead and use the distributive property to remove parentheses on the right side. 25 times x is 25x, and 25 times 15 is 375. So this is a linear equation now. The variable's exponent's just 1, so I want those variable terms to be on the same side. I'm going to subtract 25x from both sides of the equal sign. Then we'll have just 5x on the left equals 375. And we only need the multiplication property here to divide 5 from both sides of the equal sign. And we will find that x equals 75. Okay, so what does x stand for? Let me go back up here. X is the speed of the motorcycle, so 75, and if this is miles and this is hours, this is miles per hour, so this is miles per hour for the speed. Does that seem reasonable for the motorcycle to be going 75 miles per hour? Let's see what the car's speed is then. If I add 15 to that, that's going to be 90 miles per hour. So does that seem reasonable? Well, what's the context of the situation? They are traveling on the Wangan in Greater Tokyo. And it seems like excessive speeds here. But the Wangan is a famous strip for racing, so that's why these speeds are very high. And you can double check the answer if you want by plugging that in for the rate times time. So if your rate is 90 and we didn't find the time, so we'd have to do that, 30 divided by 90. And so that would be 1/3. And 90 times 1/3 is 30. So that's true. And same thing for the motorcycle. Speed times the time equals the distance. And 25/75 is 1/3 hours. And that actually does work out. So we've double checked this and this is perfect.